Fantastic. All right, so we're gonna get started. My name is Fiorella Sist, but a lot of people just call me Fee. So much easier. I'm a project director with Hargrove Engineers and Constructors. We're a full service engineering firm. And something that happens a lot when clients from the battery sector, whether it's upstream, midstream, or downstream market sectors, a lot of times they're unsure of what the journey looks like from conceptual design of a prototype to a full-scale plant. And if you don't know, then you're likely to fall into some sort of trap. And what I'm going to show you is what does that path to commercialization look like? And hopefully it's going to avoid any potential traps for you in the future. So why do battery projects fail before they scale? A lot of people say, well, we didn't have enough money, or not enough time, or not enough people. Well, really, a lot of times is not knowing what comes next. All right. So what does a project look like? Well, we have what's called the FEL. And at the bottom of the screen, as you can see, the acronyms are shown. Front end loading. That's what the FEL. So you have the FEL stages 0, 1, 2, 3, 4, and it goes past 4 as well. So 0 is that ideation stage, right? And you're doing lab tests and you have maybe a benchtop prototype. But then that's the next stage from that is what's called the FEL1. So it's also known as a preliminary economic assessment. So that is your red light, green light. Does it make sense? It works. You made it in the laboratory, but plus or minus TIC estimate. And what does TIC mean? Total installed cost. Meaning if I were to build a plant, a commercial scale plant, how much is that going to be? Is that a $500 million plant? 200 million? 1 billion? And what is your return on investment? So you're going to make a bunch of widgets or battery raw material. How long is it going to take for your investors that invested cash in this for them to make some money? So that's the plus or minus 50% is your margin of error in order to give you a red light, green light, whether the project makes sense. Then it passes on to the next stage, which is called FEL2, which is a feasibility study. And here you're starting to make some major decisions on what the plant is going to look like. And the reason it's plus or minus 30% is now you're taking on less guesstimates, and you've determined size and what type of equipment, how much space do you need, how many people. It becomes more determinate, and that's why you have a more accurate figure. At this stage too, you also start to understand what you're permitting and all the other activities that need to happen. And then this brings you to the FEL3 stage, which is now you have a plus or minus % error of how much is that project really going to cost. And this is really before getting to what's called the FID, which is final investment decision. And you will hear this as you're developing a project, this term, FID, it will be part of your vernacular for sure. Also at this stage is, what are the long lead equipment? A lot of these plants require specialized material or specialized equipment. And you'd be surprised, you will find out that it might take 12 months for you to place an order and receive the materials or the equipment, for even more than 12 months, especially when you are competing with others out there that are also building plants and requiring that material as well. And at this stage, sometimes you have to make an early decision to put your orders in for long lead materials, all right? Now, once you've gone through those FEL stages, this is where you actually get to the nitty gritty, what's called the detailed engineering and design, the procurement of the equipment, and the permitting for both the construction and the environmental aspects, which then leads to constructing the plant, installing all the pieces of equipment that's required, and then having your commissioning team on site for the commissioning and start out. All right. So all of those activities that I mentioned need to come through. So if we look at that, and I put that just on one slide, you have that engineering and construction, first green row going through the FEL stages that then leads to the detailed design, construction, commissioning, right? But along that line, usually what happens is the clients that come to us, they're really just looking at the technology transfer. You know, they have the lab testing, and the pilot testing, but all of this is going concurrent to the actual engineering, right? Also at the beginning, there's if it's not like a mine site where you have no choice, that's where the project is going to be. A lot of times our clients come to us asking, requiring assistance for site selection. We want to build this recycling plant, or we want to build this, battery cell plant. But where should I build it? Louisiana, Florida, Oklahoma? Well, there are very big differences, and it depends how much water you need, how much energy or land use, what kind of permits environmentally are you going to run in? What does your supply chain look like? Your feedstock coming in, and then your products going out to which customers, which offtakes. So this then goes into what kind of permits and approvals do you need, and the people that you need to actually start up the plant, operate it, and maintain it, right? So all of these things need to play together, and the FEL structure helps you to get you there. So here's a one sheet that shows all the key activities as well as deliverables. And when I say deliverables, I'm talking about engineering designs, the plans, the check sheets that are created at each stage. Now, you'll see my contact information there. This is a very valuable piece of information, a really nice chart to have. You are very welcome to contact me, and I'll send you this document free of charge. I'm gonna charge you for it, but this is going to give you a really good idea of all the activities and the pieces of information that need to be created for your project. Now, how long does it take, right? This is another trap that people fall into, not realizing how long do these typical projects and phases take. Now, notice at the top, I have a $200 million size project. That tends to be sort of like in the middle of the road. So for example, that the FEL stages also brings into account building smaller plants, modular plants, that then you want to build a bigger one, or maybe just a demonstration plant. Those are typically $50 million to much larger factories that are like $1 billion or multiple $1 billion, right? That's why we chose 200 million just to give you the story. It's gonna change. What I'm gonna show you is a typical timeline. Don't think that this is gospel, all right? So what does it look like? An FEL1, right? This is the preliminary economic assessment, 1 to 3 months, all right? Once you've achieved that, you have your green light, red light. Does it make sense? You have your 50 plus or minus 50% TIC. Then you get into, you're looking at your FEL2, your feasibility. That is a 4 to 6 months, right? Now that gives you your plus or minus 30% TIC, total installed cost, and you start to formulate a clear idea of what the plant is going to look like, exactly what pieces of equipment you need to buy, and you're making decisions of final designs, right? Of what path you're going to take. Now, at the FEL3 stage, right? Now, this is your plus or minus 10% for FID, right? This is your financial decision of going forward. This is what your investors will definitely need to have. 5 to 9 months, right? And you have a clear idea at this point of what your long lead items are, which is going to be your critical path to how long it's going to take to procure your equipment and to actually construct your plan, right? And then detailed engineering design, you're looking at typically a 12 to 14 month timeline, all right? Also, keep in mind, as you can see there, with after the construction and installation, which is 12 to 18 months, you have to commission and start up the plant. This is another trap that we see our customers fall into. Not realizing that you're not going to just once everything is mechanically completed, that you're just going to turn the plant on like a button, like a start button, and walk away. It will take months. And especially if you're supplying to, let's say, the automotive industry, you have to have your product qualified. And that qualification period takes a long time, right? So you need to build that into your schedule. All right, so if you look at the total timeline from detailed engineering and design, which is that DD, to MC, which is mechanical and completion, that's like 26 to 30 months, all right? So that's a shocker, I know. All right. So here's a typical Gantt chart. It's just, it shows you that it's multiple years and what the stages are. Definitely, there's a bit of concurrence of activities that are going on there. But, this just gives you a good snapshot. Now, can you compress that schedule? What are some of the things you can do to compress? Yeah, there are. I already told you about long lead items. If you know much more ahead, like in the FEL2 stage, in the beginning of the FEL3, what your long lead items, and you could place that order immediately, you got funding to do it. This will definitely help to compress the schedule. Other things too is site preparation and demolition. Let's say you have the plot of land and you have to do your site works, or you have to demolish a very old structure to build a new structure. You can do that concurrently, right? And engaging with your contractor early on in the process, if you've already selected your contractor, this too. So there are things that can be done, and it all depends on whether you have the funding to do it, or whether you have already the land ready to go in order to get done. All right, so why go through the FEL stages? Well, I'll show you why. And if you don't, these are the traps that you can fall into. Now, when you're in the early stages, you're close to the conceptual analysis, you're going to have a major influence of what the future is going to look like. You can determine where you're going to build the plant, what sort of flow sheet or equipment you're going to have. You're going to make very significant decisions that will completely dominate what your final commercial plant is going to look like. However, as you get more down the, the progress of the detailed design, purchasing equipment, constructing, installing it, the chances of you to go in there to make a significant change, because let's say you determine that there's a more cost-effective way or a more environmentally friendly way to design and construction and operate the plant, well, guess what? To reverse decisions, to unbuy equipment, to uninstall equipment that you newly installed, that's going to cost a lot of money and definitely going to make a huge impact to your overall timeline, right? So the FEL stages helps you, you're going to go through that process anyway, so why not do it at the right stage, at the right point of time? So in order to avoid headaches in the future, right? So the FEL stages are best practices, right? These are the lessons learned through others who have failed so many times. And this over time has been formulated as the best way to run your project, right? So we're just an engineering firm. We've got 17 offices across the US. More than happy to help you guys if you have any more questions on this. And I know there's I really hope you guys don't fall into the trap, and hopefully this gives you some ideas of what to do next. Any questions?
Does Hargrove